speaking, here is example 5 from the 5.3 notes. They have introduced the idea that we're using rational exponents here instead of any sort of a radical. So we're not going to attempt to graph these. They're just more fun to do algebraically. So in this case, the first thing I want to do is add 2 to both sides. So that gives me 3x to the 3/4 equals, I'm leaving space there intentionally, you might want to do the same thing, equals 27. Now I'm going to need to raise both of these equations to the reciprocal of the exponent, because when I raise a power to a power, right, close your eyes, remember this rule? If I have a to the m to the n, that's really a to the m times n. So in this case, I'm going to be raising both sides to the reciprocal of this exponent, so that when I multiply them together, the exponent will just be 1. So I'm going to raise both sides to the 4/3 power. Now, just a word of caution, it doesn't apply to this problem, but if this number was negative and I was raising it to the 4/3 power, some calculators don't like that, so if we come across that, you'll have to separate that into taking the cube root of the negative and then raising it to the 4th power. It doesn't apply here because we're working with a positive 27, but just letting you know if your calculator freaks out. Sorry about that. Okay, so the left side, as we said, 3/4 times 4/3, that's just 1, so we're left with 3x, which is perfect, that's what we want. The cube root of 27 happens to be 3, so 3 raised to the 4th power is going to be 81. So I have 3x equals 81. All of this I can also put into my calculator like this. If I can get a spot here where it's not a glare. Okay. So if I said parentheses 27 caret, what do we say, 4 divided by 3? That will just pop out 81, no problem. So that's what that looks like in your calculator. So then dividing this by 3, it's probably clear to you our answer is going to be 27. So that's the answer for that one. Here is example 6, and then we'll have you try it. Same idea. So it's the quantity x plus 12 to the 1/2 power equals x. So I'm going to raise both sides to the 2nd power, because the reciprocal of 1/2 is 2. And that gets me just x plus 12 on the left equals x squared on the right. I'll move this over because I perceive this is a trinomial that I might be able to factor, or worst case scenario, use the quadratic formula. So this looks like that it will factor as x minus 4 times x plus 3. And that means x minus 4 equals 0, or x plus 3 equals 0. Either way, you should be able to identify these as the x-intercepts and know that they change sign. So x equals 4 would be one point, and x equals negative 3 would be another x-intercept. So do both of these work? Let's take a look. So we have 4 plus 12 to the 1/2, does that equal 4? So 16 to the 1/2, that does equal 4. So that's an answer. What about when we have negative 3 plus 12 to the 1/2? Does that equal negative 3? I'm feeling kind of concerned about this. Ooh, close your eyes. Open your eyes. Okay, so this gives me a 9 to the 1/2, which is 3, but not negative 3. So that answer does not satisfy the original equation. Okay, here's a you try it. Close your eyes. Open your eyes. So example 6, you try it. I would like you to solve that seems kind of... Let's go with x plus 2 to the 3/4 equals 8. So again, I'm going to raise both sides to... Oh, you should pause this and try it and start again. I'm going to keep going. To the 4/3. That leaves me with x plus 2 on the left. And that will leave me with 2 to the 4th power, because the cube root of 8 is 2. 2 to the 4th is 16, so it seems like x is going to equal, what's that give me, 14? So that should work out. Yeah, and the book agrees with me. Okay, so very last thing we need to do is example 7. Close your eyes. And maybe write a note about when we need to check our solutions. They want us to solve 3 times this. That's there, but you want me to use other examples? Hold on. What is the extra example? Oh. 3 times the square root of x minus 4 is less than or equal to 8. So I'm going to move the 4 over. So I have 3 times the square root of x is less than or equal to 8 plus 4 is 12. I'm going to divide by 3. Now, please remember, Kings, if this coefficient that you're dividing by is negative, then you're going to need to change the inequality symbol here. Because anytime you multiply or divide by a negative, the inequality symbol turns over. So this is the square root of x is going to be less than or equal to 4. And if I square both sides, I'll have x is less than or equal to 16. Now, we haven't spoken very much about the domain here, but under the radical, we have x, right? And because it's a square root, we don't want the radicand to be a negative number. So x can go between like 0, right? Because I need this. So this actually is the solution step, because we can't have -1 under here. So let's try another one of those, because I want a more complicated radicand. Well, that's not super great. Here's number 40. They want us to solve not what we need. Oh. Well, they're going easy on you. So it works out that anytime we're going to have a square root in the homework, it's just going to be a simple x, and you know that you don't want a negative under there, so the smallest value should be 0. Here's let's run example 7. I don't know if I want to call it a you try it, because it's with a cube root, and we haven't really done that, but here they want us to solve, or I want us to try, that's a little sketchy, 4 times the cube root of x plus 1 is less than 8. Are these all going to be less than? No, that's also shady. Okay, super. Alright, anyways, so in this case I'm going to divide both sides by 4. And I have the cube root of x plus 1 is less than 2. I'm going to raise this to the 3rd power and this to the 3rd power. So now I'm left with x plus 1 on the left is less than 8. When I subtract 1 from both sides, I'll have x is less than 7. Because this is a cube root, there's no reason for me to have a lower boundary, because I can have negatives under there, under the radical, when it's a cube root. So that's our answer. Let's see if we can find some other fascinating stuff. Here's number 39 from your homework. Let's do 42 instead. So they want us to solve. They gave us the cube root of x plus 7 is greater than or equal to 3. So if I solve this, of course I'm going to raise both sides to the third power. That leaves me with x plus 7 on the left is greater than or equal to 27, and x is greater than or equal to 20. That's not that scary. I thought it was going to be worse. Perfect. That's it. Okay. I hope that's enough examples for you. It's definitely enough examples for me. If you have questions, we're going to try to work through this homework assignment tomorrow during class. Okay? See you soon, Kings. T minus 11 days till the holiday break. Woo woo!